Okay, so our next speaker is, I think, Butler. Let me just make sure. Yes, Butler Lamson, also from our lab, and he will talk about unusable security.
Oops. Well, I was going to talk about unusable security, but I changed my mind the day before yesterday. And I'm going to talk about retroactive security instead. So what could that possibly mean? Why would you want security to be retroactive? Well, the classic way to do security is so-called access control. And we've been trying it for 40 years, and basically it doesn't work. And there's two reasons for that. One is bugs, which I'll talk about later, and the other is that the job of access control is to say no. And when you're trying to get your job done, you don't want the system to say no. So the tendency is for the system to evolve towards saying yes, and thus being less secure. The other reason, second reason why retroactive security makes sense is real-world security is retroactive. The reason that burglars don't break into my house is not that they can't get through the lock on the front door or break through a window. Of course they can. It's because although the risk of being caught and sent to jail is small, it's big enough to make the whole proposition uneconomic. Similarly, the security of the financial system doesn't actually depend on vaults and encryption and all that stuff. It depends on the fact that almost everything in the financial system can be undone. The third reason why you want to do things retroactively is that the best is the enemy of the good. People have had this dream that we understand exactly how computers work, and therefore we should be able to build systems that are perfectly secure. And we've been trying to do that for 40 or 50 years, and what we've learned is that you can only do it for very small, very bounded, self-contained systems, which are typically not the kind of systems that we want. Just a brief word about access control, the classic way of doing things. The idea is, the model for access control is you have some resource that you're trying to protect, you wrap it in an isolation boundary. When requests come in from the outside to do things, they pass through a guard whose job it is to decide whether or not the request should be granted. That's the classic way of doing business. So how does retroactive security work by contrast? What about blame? How do you attribute blame when something goes wrong? Roughly speaking, the idea is you use the access control ideas only to keep out people that you can't punish. Everything else you deal with by punishing a misbehaving person. How does that work? Well, you make some common sense rules. You let the individuals override the machine's blind enforcement of its version of the common sense rules. But you do log all the accesses. Every time somebody does something, read or write, you log who did it and what it was that was done. If you notice problems, then you use the log to find the culprits. In addition, you can mine the log looking for unusual behavior, especially cases where some user decided to override the machine's interpretation of the rules. To make this work, you do need good authentication so that you know who took the actions. And you also need an audit log, which is reasonably easy to look at and to study, which is not something that we typically actually have. What about integrity? People worry a lot about, probably the thing that people worry about most in security is that their data might get corrupted. The retroactive way to approach this problem is selective undo. What's the idea here? You log all the state changes, their inputs and their outputs, and if your system gets corrupted, you fix it by resetting it to some old state that you think is good, installing patches blocking known attacks that were made on the system since that point, and then you replay all the logged actions except the blocked ones. And you might think that isn't going to work because it's going to take too long to replay all the actions. However, most of the actions are going to have the property that their inputs are unchanged and the actual code of the action is unchanged, and therefore the outputs are going to be unchanged. So you don't actually have to replay the action. You can just take the output from the log. Of course, this doesn't always work, but it works amazingly often in practice. Sometimes it needs user input to resolve the conflicts. If it needs too much user input, then it collapses under its own weight. But it's quite surprising that on a very large fraction of the time, it can work without any user assistance. What about secrecy? Here the idea is a little bit more subtle. We want to be able to undo publication. How can you stop the internet from remembering your nude photo forever? So here the idea is, when you post something, you tag it as yours. And well-behaved applications and services like Google and Facebook and Outlook and so forth will respect the tags. What does it mean to respect the tag? First of all, it means that whenever you copy the data around, you copy the tag with it. And secondly, it means that whenever you do anything with the data, you consult the current policy for the tag. That means you go to some website which is associated with the tag, and you see what the current rules are for dealing with that data. And those rules can change. If it's my data, I establish the policy. I can go in there and say, I don't want anyone to see that nude photo anymore. So that's the way you take it back. Now, of course, if someone has copied the nude photo onto their own hard drive and removed the tag, then they're not being well behaved, and there's nothing the system can do about that. So it doesn't solve all the world's problems. But it does mean that information is not going to be out there on Google or Facebook or manipulated by Office or Photoshop or other well-behaved applications, which is not perfect, but it makes things much better than they are now. What about bugs? As I mentioned earlier, one of the big problems with access control is that there are bugs, and if any bug can make trouble for the access control, and since the access control is a prospective way of doing things, that's fatal. And our experience tells us that except for very small and very narrowly defined systems, we always have bugs that subvert the access control. So we have to remember real-world security is not about locks, it's about deterrence. The problem we have today is that on the net, you can't find the bad guys, so you can't deter them. So what's the fix for that? The fix is refuse inputs that are not accountable enough. If an input comes into your system from some place that you can't punish, you should throw it on the floor. That will prevent it from tickling a bug. And what's the meaning of accountability? Accountability means someone is accountable if you can punish them. Punish doesn't necessarily mean that you're going to send them to jail. It might mean that they're going to be fined, or they're an employee who's going to be disciplined or fired, or they're a friend whom you're going to ostracize or whatever. The basic notion here is you get to decide what constitutes a sufficient amount of accountability and balance that against what you think is the value of the information that you're protecting. The obvious problem with this accountability idea is if I want to browse the internet freely, there's a lot of stuff out there that I want to look at that's not particularly accountable. So how can we deal with that? The answer to that is sort of obvious. You divide the world into two parts, a green part, which contains stuff that you care about, and a red part, which you can think of as a playground where you live wild and free. In the green part, you demand accountability. So for example, if you're very conservative and you say my green part is only for my financial transactions, then the only things I'm going to do on the green part are to talk to my own bank. The red part, I can talk to anybody. If it runs into trouble, you just push the reset button. And that's okay because it doesn't have anything in it that's important to you. So to sum this up, access control hasn't worked. We should learn from the way real-world security works, which is retroactively. We should do auditing. We should have selective undo. We should establish ownership of data that's published on the internet. And for bugs, we should have accountability. Thank you.
Okay, thank you, Butler. For this thought-provoking talk, and we have time for a few questions.
Surely there are questions or anguished complaints or something.
Can you go to the microphone there? I like your analogy to punishing criminals. And so I just want to ask you what happens in the auditing if you have a conspiracy, an interaction among many bad things that happened. How hard is it to find that interaction rather than one bad thing that happened?
Well, it can be quite difficult. I don't know if you know the story of the Stuxnet virus that attacked the uranium separating centrifuges. That was about 6 bad things had to happen in order to get them into trouble. So it can be difficult. Life is hard. It's not as though it's not as though either this approach is going to be perfect or the current way of doing things is so wonderful that we shouldn't try to improve it.
Any more questions? OK, then let's thank Butler again. OK, our next